Question 1. From multiple perspectives, a facility manager notices fluctuating return air temperatures in a valve system despite stable supply temperatures. What is the most likely cause? A. Malfunctioning zone dampers. B. Overloaded supply fans. C. Insufficient refrigerant charge. D. Faulty expansion valve. Answer. Correct answer. A. Explanation. Malfunctioning zone dampers can cause uneven airflow distribution, leading to return air temperature fluctuations even when supply air remains steady. This is common in valve systems where dampers regulate zone demand. Overloaded supply fans, B, would cause pressure instability, not temperature fluctuations alone. Insufficient refrigerant charge, C, affects coil temperatures and supply air, not just return. A faulty expansion valve, D, would influence evaporator performance and supply air cooling, not cause zone-specific return temp variation. Ref. ASHRAE 62.1 Valve Balancing Practices. Question 2. When evaluating the merits of a cooling tower water treatment program, which factor is most critical for preventing scale buildup? A. Continuous chemical feed. B. Blowdown rate control. C. Basin heater operation. D. Seasonal layout procedures. Answer. Correct answer. B. Explanation. Blowdown rate control ensures dissolved solids remain below scaling thresholds, preventing mineral deposition on heat exchange surfaces. Continuous chemical feed A helps, but without blowdown control, concentration cycles will still cause scale. Basin heaters C prevent freezing, unrelated to scale prevention. Seasonal layup D prevents corrosion during idle periods, but not scaled operation. Proper blowdown integrates with conductivity monitoring for optimal control. Ref. CTI Guilelity 148. Question 3. Given the circumstances, Mr. Alvarez is troubleshooting a chiller showing higher than normal approach temperatures at the condenser. Which action is most appropriate first? A. Inspect condenser tube fouling. B. Add more refrigerant. C. Replace condenser fan motors. D. Adjust chilled water set point. Answer. Correct answer. A. Explanation. High condenser approach temperatures typically indicate reduced heat transfer, often from tube fouling or scaling. Cleaning tubes restores efficiency. Adding refrigerant B. Without diagnosis risks overcharge. Replacing fan motors C. is unnecessary unless airflow is proven inadequate. Adjusting chilled water set point D. addresses load, not condenser efficiency. Always verify mechanical cleanliness before altering operational parameters. Ref. RE 500 590 chiller performance troubleshooting. Question 4. Throughout the course of an air balancing project, the technician finds several diffusers delivering less airflow than specified despite proper damper settings. What is the likely underlying cause? A. Undersized supply trunk. B. High static pressure drop in filters. C. Leaky return ductwork. D. Malfunctioning thermostat. Answer. Correct answer. C. Explanation. Leaky return ductwork can lower system airflow and create pressure imbalances, reducing delivery at diffusers despite damper adjustment. An undersized truncate would cause consistent underdelivery across all diffusers, not selective. High filter pressure drop B reduces system-wide flow, but if supply pressures are fine, it's less likely. Malfunctioning thermostat D wouldn't cause localized diffuser underdelivery. Sealing return ducts improves balance and efficiency. Ref. SMACNA duct leakage standards. Question 5. By evaluating psychrometric readings, a building operator notes a 10° difference between dry bulb and wet bulb temperatures in return air. What does this indicate? A. High humidity load. B. Low humidity load. C. Sensor calibration error. D. Excessive infiltration. Answer. Correct answer. B. Explanation. LWE difference indicates relatively drier RWE approaches EB when humidity is high. High humidity load A would show a smaller difference. Sensor error C would be inconsistent with other system readings. Excessive infiltration D could change humidity but needs confirmation. Here readings match low moisture. Understand WE differences is key in diagnosing latent versus sensible loads. Ref. ASHRAE Fundamentals Psychrometrics Chapter. Question 6. As illustrated by Istachen's maintenance logs, the same rooftop unit repeatedly trips on high head pressure during peak afternoon load. Which action is most effective long-term? A. Increase condenser fan speed. B. Install shade over the condenser. C. Clean condenser coils. D. Replace the expansion valve. Answer. Correct answer. C. Explanation. Dirty condenser coils insulate heat transfer surfaces, causing head pressure to rise, especially under high ambient temperatures. Increasing fan speed A can temporarily help but may exceed motor design. Shading B offers minor benefit compared to restoring core cleanliness. Replacing the expansion valve D would not address condenser side heat rejection issues. Regular core cleaning is a best practice maintenance RAF OEM maintenance guidelines. Question 7. The prevailing attitude toward energy efficiency suggests which upgrade yields the greatest ROI for older constant volume air systems? A. Installing ECM motors. B. Retrofitting to VAF control. C. Adding heat recovery wheels. D. Increasing filter MERV rating. Answer. Correct answer. B. Explanation. Retrofitting constant volume to VAV allows fan energy savings, better load matching, and reduced heat energy, offering high ROI. ECM motors improve efficiency but less dramatically than VAV conversion. Heat recovery wheels C are beneficial but capital intensive with longer payback. Higher MERV filters D improve IAC but increase pressure drop, often raising energy use. VAV control upgrades target major energy drivers. RAF ASHRAE Energy Efficiency Retrofit Guide. Question 8. In contrast to air-cooled chillers, water-cooled chillers are generally more efficient because A. Water has higher thermal conductivity than air. B. Compressors run at lower speeds. C. Pumps consume less power than fans. D. They use fewer moving parts. Answer. Correct answer. A. Explanation. Water's higher thermal conductivity and heat capacity allow better heat rejection, enabling lower condensing temperatures and higher efficiency. Compressor speed B depends on design, not chiller type. Pump versus fan energy C is not the primary driver. The cooling tower fans also consume power, fewer moving parts. D is inaccurate. The component complexity is similar. The medium's heat transferability is the factor. RAF RE chiller performance standards. Question 9. From the perspective of Ista Green, who is reviewing indoor air quality complaints of musty odors, which step is most appropriate first? A. Inspect and clean condensate drain pans. B. Replace supply diffusers. C. Increase heating coil temperature. D. Install ultraviolet germicidal lights. Answer. Correct answer. A. Explanation. Musty odors often originate from microbial growth in wet drain pans. Cleaning and ensuring proper drainage addresses the source. Replacing diffusers. B. Treats symptoms, not cause. Increasing heating coil temperature. C. Doesn't resolve moisture or biological growth. UV lights. D. Can help prevent growth but are more effective as preventive measure after cleaning. Drain maintenance is core IAC best practice. RAF ASHRAE 62.1 IAC maintenance. Question 10. Examining the consequences of reducing preventive maintenance frequency on a house, what is the most likely long-term impact? A. Reduced occupant complaints. B. Increased energy consumption. C. Improved coil efficiency. D. Lower maintenance costs overall. Answer. Correct answer. B. Explanation. Skipping maintenance allows dirt buildup on coils, filters, and fans, increasing resistance and reducing heat transfer, which raises energy consumption. Occupant complaints A. Often increase, not decrease. Coil efficiency C. Declines without cleaning. Low maintenance costs D. Are short-term only. Breakdowns and inefficiency drive long-term costs up. Preventive maintenance is an investment in both reliability and efficiency. Ref. BOMA Preventive Maintenance Guide. Question 11. Considering the evidences, Porter observes that the building's heating system cycles on and off rapidly during mild weather, leading to uneven comfort levels. What should be investigated first? A. Oversized boiler capacity. B. Thermostat location. C. Damaged pump impeller. D. Dirty burner nozzles. Answer. Correct answer. A. Explanation. Short cycling in mild conditions often indicates an oversized boiler, as it meets the load too quickly, shutting down and restarting repeatedly. This wastes energy and causes temperature swings. Thermostat location B can affect cycling if exposed to drafts or heat sources, but here symptoms match capacity oversizing. Damaged pump impellers C cause poor circulation, not rapid cycling. Dirty burner nozzles reduce combustion efficiency but don't inherently cause frequent on-off operation. Ref. ASHRAE HVAC applications, boiler sizing guidelines. Question 12. In the absence of proper duct insulation, what is the most likely outcome for supply air temperature in unconditioned spaces? A. It will drop in cooling mode. B. It will rise in cooling mode. C. It will remain unaffected. D. It will become unstable in both heating and cooling. Answer. Correct answer. A. Explanation. Without insulation, cool supply air passing through hot unconditioned spaces will absorb heat, causing temperature rise at the coil but appearing as a drop in cooling delivery at the register. In heating, the opposite occurs. Heat is lost to the surrounding space. Option B is incorrect because the measured register temp during cooling will be warmer, not cooler. Option C ignores conduction. Option D is partially true but lacks the precision of the correct explanation. Ref. SMACNA duct design standards. Question 13. Under the assumption that Mr. Bennett's VRF system is showing poor zone temperature control despite no refrigerant fault, what is the most probable cause? A. Improper branch selector box operation. B. Incorrect refrigerant type used. C. Oversized indoor fan coils. D. Faulty outdoor unit inverter. Answer. Correct answer. A. Explanation. In ERF systems, the branch selector box directs refrigerant flow for simultaneous heating and cooling. A malfunction here can cause incorrect mode operation in certain zones, leading to poor control without triggering refrigerant alarms. Using the wrong refrigerant, B, would cause major performance issues and alarms. Oversized fan coils, C, may short cycle but typically still reach set point. A faulty inverter, D, would impact all zones, not selected ones. Brett ERF manufacturer service manuals. Question 14. In comparison with a constant air volume system, which of the following is the primary energy efficiency advantage of a VAV system? A. Constant airflow at all loads. B. Reduced fan energy at part load. C. Higher duct pressure at peak load. D. Increased reheat energy. Answer. Correct answer. B. Explanation. VAV systems reduce fan speed at part load, directly lowering fan energy consumption, often yielding the largest savings in HVAC retrofits. Constant airflow A describes KEV, not VAV. Higher duct pressure C increases energy use. Increased reheat energy D is a drawback in some VAV designs, not an advantage. The correct principle is fan loss savings. Iwikwas kubwa airflow reduction. Ref. ASHRAE efficiency guide for existing commercial buildings. Question 15. The foundation of cooling tower performance lies in which key operational factor? A. Wet bulb temperature of entering air. B. Dry bulb temperature of entering air. C. Barometric pressure at site elevation. D. Condenser water inlet temperature. Answer. Correct answer. A. Explanation. Cooling towers reject heat via evaporative cooling, which is governed by the wet bulb temperature of entering air. This sets the theoretical limit for condenser water cooling. Dry bulb temperature B matters less since evaporation dominates. Barometric pressure C affects density slightly but is not the main performance determinant. Condenser water inlet temperature D is a load condition, not the driving ambient factor. RAF CTI cooling tower fundamentals. Question 16. From a practical standpoint, Mr. Dyers notes that occupants on the top floor complain of insufficient cooling every afternoon, but supply temperatures are normal at the AHU. What should be checked first? A. Duct static pressure to top floor. B. Refrigerant subcooling. C. AHU fan belt tension. D. Filter differential pressure. Answer. Correct answer. A. Explanation. If AHU supply temps are fine, but upper floors receive insufficient cooling, duct static pressure measurement can reveal if vertical duct losses or balancing issues are preventing proper airflow. Subcooling B affects coil performance, but here coil temps are normal. fan belt tension. C. Impact all floors equally. Filter pressure drop. D. Would also affect the entire building. Targeted static pressure checks flow distribution problems. Ref. SMACNA air balancing guidelines. Question 17. Examining the consequences of using a higher than specified MRF filter without fan adjustments, what is most likely? A. Increased airflow. B. Reduced airflow. C. Unchanged energy consumption. D. Improved dehumidification. Answer. Correct answer. B. Explanation. High MRF filters increase resistance, lowering airflow. Fan speed or capacity isn't adjusted, which can reduce comfort and efficiency. Increased airflow. A. Contradicts added resistance. Energy use. C. Usually rises due to higher fan effort to maintain flow. Improved dehumidification. D. May occur slightly if coil contact time increases, but reduced total capacity often offsets benefits. Ref. ASHRAE 52.2 filtration standards. Question 18. With respect to energy management, which operational adjustment offers significant savings with minimal capital cost in an existing HVACR plant? A. Lowering supply water temperature in chilled water systems during partial load. B. Installing new VVFDs on all fans. C. Replacing all chillers with high-efficiency models. D. Adding a secondary cooling tower. Answer. Correct answer. A. Explanation. Lowering chilled water supply temperature set points during partial loads reduces chiller lift, improving efficiency without major investment. Installing VVFDs. B. Can save energy but costs more upfront. Replacing chillers. C. Is high capital cost. Adding a secondary cooling tower. D. Increases redundancy but not necessarily efficiency unless integrated with load management. Ref. Do Advanced Energy Retrofit Guide. Question 19. Historically speaking, what was the main driver for the transition from pneumatic to direct digital control (DDC) in HVAC systems? A. Lower installation costs. B. Enhanced precision and programmability. C. Elimination of all maintenance requirements. D. Simpler troubleshooting. Answer. Correct answer. B. Explanation. The shift DDC was driven by the ability to precisely control, schedule, and monitor systems, enabling complex strategies and integration with BAS. Lower installation cost. A. Was not the main factor initially. D. Or expensive early on. Maintenance. C. Is still required, albeit different in nature. Troubleshooting. D. Can be easier with digital trends, but complexity sometimes increases. Ref. Handbook. HVAC Applications. Controls Chapter. Question 20. When faced with fluctuating humidity levels in a building despite stable temperature control, what is the most probable root cause? A. Faulty humidistat. B. Oversized cooling equipment. C. Low refrigerant charge. D. Blocked supply diffusers. Answer. Correct answer. B. Explanation. Oversized cooling systems cycle too quickly, removing sensible heat but not running long enough to dehumidify effectively, leading to fluctuating. Alright, a faulty humidistat may cause control issues but wouldn't cause persistent load mismatch. Low refrigerant. C. Reduces both cooling and dehumidification capacity, typically with noticeable temperature issues. Blocked diffusers. D. Cause and distribution, not systemic humidity swings. Ref. ASHRAE Fundamentals, Moisture Control in Buildings. Question 21. To better understand a facility's chiller plant and efficiency, ISTA Lawson logs condenser water temperatures and finds they are consistently 8 degrees above design. Which step is most effective to restore performance? A. Increase chilled water flow rate. B. Clean cooling tower fill and strainers. C. Lower evaporator temperature set point. D. Add chemical scale inhibitors. Answer. Correct answer. B. Explanation. High condenser water temperature often indicates poor cooling tower heat rejection, commonly caused by fouled fill or clogged strainers restricting water distribution. Increasing chilled water flow. A. Doesn't address condenser side inefficiency. Lowering evaporator set point. C. Increases chiller lift and reduces efficiency. Adding scale inhibitors. D. Helps prevent future deposits but won't immediately fix the problem caused by physical fouling. Ref. EIRations Manual. Question 22. When presented with a new Wahoo design, the engineer notes the inclusion of an economizer cycle. What is the main advantage of this feature? A. Reduced heating demand during winter. B. Increased cooling capacity without compressors. C. Lower static pressure in ductwork. D. Dehumidification during mild weather. Answer. Correct answer, B. Explanation. Economizers bring in cool outdoor air when conditions allow, reducing mechanical cooling by using free cooling. Reduced heating A is not the primary benefit. Economizers can increase heating needs in some cases if not controlled properly. Static pressure C is unaffected by economizer operation, while dehumidification D might occur if outdoor air is dry. This is secondary to its main role in low compressor energy use. Ref. ASHRAE 90.1 Economizer Requirements. Question 23. Through careful analysis of supply and return temperature logs, a building operator notices the return air temperature is only 2 degrees lower than supply air temperature during cooling. What is the most likely cause? A. Excessive infiltration of outdoor air. B. Blocked evaporator coil. C. Incorrectly calibrated thermostat. D. Low indoor air circulation. Answer. Correct answer, A. Explanation. Excessive infiltration of warm, humid outdoor air can reduce the effective temperature drop across the conditioned space, making return and supply readings closer. Blocked coils, B, would cause a larger supply temperature rise and possibly freezing. Thermostat calibration, C, affects set point accuracy but not measured temp split directly. Low circulation, D, causes uneven cooling but usually shows a normal difference in measured zones. Ref. ASHRAE Fundamentals. Load calculations. Question 24. The impact of high static pressure in a duct system is most likely to result in A. Increased airflow to terminal devices. B. Reduced fan power consumption. C. Decreased delivered airflow. D. Higher filter bypass leakage. Answer. Correct answer, C. Explanation. Excessive static pressure increases fan workload and can choke airflow if the fan cannot overcome resistance, leading to reduced air delivery. Increased airflow A is impossible under high resistance without increased fan capacity. Reduced power consumption B is the opposite. If fans draw more power, higher filter bypass leakage D can occur but is not the primary or most consistent outcome compared to direct airflow reduction. Raft's Magna Air Systems Design Manual. Question 25. As a result of inadequate cooling tower maintenance, the condenser approach temperature in a chiller rises steadily over weeks. What is the most direct operational consequence? A. Lower evaporator pressure. B. Higher compressor energy use. C. Reduced refrigerant superheat. D. Increased chilled water delta T. Answer. Correct answer, B. Explanation. A higher condenser approach forces the compressor to operate at higher head pressure, increasing energy consumption significantly. Lower evaporator pressure A is not a direct result. Condenser conditions don't always dictate evaporator pressure unless load changes. Superheat reduction C is unrelated here. Chilled water delta T D may change, but compressor work increase is the primary immediate effect. Ref. Chiller Performance Guidelines. Question 26. During the process of converting a CAV system to VAV, the design team must ensure A. Constant duct static pressure regardless of load. B. Proper minimum airflow to maintain ventilation rates. C. Maximum airflow at all times to ensure comfort. D. All terminal boxes operate in reheat mode continuously. Answer. Correct answer, B. Explanation. VAV systems must provide minimum ventilation per code ASHRAE 62.1, even when reducing fan speeds for energy savings. Constant static pressure A is inefficient. In modern systems use static reset. Maximum airflow C contradicts VAV's energy goals. Continuous reheat D wastes energy and is only used when necessary for comfort or humidity control. Ref. ASHRAE 62.1, 90.1. Question 27. While examining a heat pump in heating mode, Istasing finds frost buildup on the outdoor coil. What should be the technician's first action? A. Activate the emergency heat mode. B. Initiate defrost cycle. C. Reduce indoor fan speed. D. Check refrigerant oil level. Answer. Correct answer, B. Explanation. Frost accumulation impedes airflow and heat transfer. Initiating a defrost cycle restores coil efficiency. Emergency heat A provides temporary heating but ignores the frost issue. Reducing fan speed C affects indoor performance, not frost removal. Checking oil level D is not relevant to defrosting needs. Defrost cycles are integral to heat pump winter operation. Ref. OEM heat pump manual. Question 20. Taking into account building envelope deficiencies, which upgrade has the most direct effect on HVAC load reduction? A. Replacing single-pane windows with double-glazed units. B. Installing new thermostats. C. Adding variable frequency drives to supply fans. D. Switching to higher MERV filters. Answer. Correct answer. A. Explanation. Double glazing improves insulation and reduces heat gain loss, directly lowering HVAC loads. New thermostats B can improve control, but don't change building thermal characteristics. VFDSC save fan energy, but don't reduce thermal loads. Higher MERV filters D may slightly affect fan energy, but not heat transfer through the envelope. Ref. Do building envelope retrofit guide. Question 29. Contrary to popular belief, lowering a thermostat setting significantly will not cool the space faster because the compressor speed increases proportionally. B. The cooling rate is fixed by system capacity. C. More refrigerant flows through the evaporator. D. The blower runs at a higher RPM. Answer. Correct answer. B. Explanation. HVAC cooling rate is determined by equipment capacity. Lowering the set point only extends runtime, not cooling speed. Compressor speed A is fixed in most systems unless variable speed, which still won't exceed maximum capacity. Refrigerant flow C and blower RPM D may adjust in modulating systems but do not exceed design cooling rates. Ref. ASHRAE Fundamentals. Cooling load principles. Question 30. The most significant aspect of maintaining optimal psychrometric performance in a dehumidification application is A. Maintaining coil surface temperature below dew point. B. Increasing outdoor air intake. C. Raising indoor set point temperature. D. Reducing supply air velocity. Answer. Correct answer. A. Explanation. To dehumidify, coil surfaces must be colder than the air's dew point so moisture condenses effectively. Increased outdoor air B can worsen humidity if not conditioned. Higher set points C may reduce latent load slightly but don't actively remove moisture. Reduced air velocity D can improve contact time but is secondary to achieving the proper coil temperature. Ref. ASHRAE Fundamentals. Psychrometrics.